Right, let's get into this week's of A1 double summary. So we topics, we have this stuff. So this is the main thing, the differentiation stuff. If it's pretty like hard, it's not something you've really seen before. In pure, it's where pure really starts getting a lot more difficult, and especially when we get to integration, it's going to get more and more difficult. And then the other stuff this week was kind of just some easy stuff. These are both year one stats topics or applied topics. And let's just get into the assignment very quickly. So this assignment was pretty okay. The first few questions did take me a while, but that's just probably because my algebraic division isn't the best. So these first few questions are really easy. I mean, it's just normal polynomial division. Get divide factors graph, divide factors graph, do the same thing. Yeah, just and because you have a quartic here, so you just need to remember what the quartic looks like and do the same thing. Next we have this one, you just substitute the values in, so substitute -2, substitute -3, solve simultaneously, get the answer. Next question, show that they equal 0, just say that they equal 0, and then do the algebraic division, you get all these solutions. Next question, you do the range, then you use the identity, get the quadratic, solve, and you get that's and then you do inverse, get the solutions, and that is your answer. Alright, next question, we got some partial fractions going on here. So this first one's really easy. I use whatever method you can use, cover up, you can use equating coefficients, whatever. But when you have simple ones, I just like to use the cover up method because it's just a lot easier and faster. So for this question, it's also pretty easy. You just factorize the bottom. This question is also easy. It's just more normal stuff. But this last one, you need to this last one you need to factorize again, and then do the same thing, get all your stuff, and then that's it. Alright, next question. I don't even know what this question was on about a lot of the time, but firstly, why did I just divide it by 1,000, multiply by 1,000 to get rid, divided by 1,000 to get rid of the 1,000, and then you can factorize that out of the derivative, so when you differentiate and you set it equal to 0, it will just set this entire thing equal to 0, and get p equals 6. Then here the revenue means that if this is the number of boxes it will sell per year, the revenue is the number of boxes times the price. So you just multiply I just wrote the same equation, but just added a p at the end. So it'd be NP equals that. Or R equals NP, basically. It's the number of boxes times the price. And then next, show the maximal revenue. You just differentiate again, where you get a quadratic, and then you solve. Right, this is just some easy differentiation stuff. You just find the maxes. You can use double derivative to get the maximums and the minimums, or you could just use think about the graph. Like, is it a positive cubic? Is it a negative cubic? Where do the stationary points land? Depending on how far, the first stationary point is a maximum on a positive cubic. The second stationary point is a minimum. Next question is just more stuff. Same thing. And yeah. Alright, this proof was ridiculous. I don't know what they expected us to do here. So this first one's really easy. You just say 2n plus 1's odd. But then this was interesting. So there's multiple things you can do with this proof. I decided to do this conglomeration of an infinite triangle going down that I vaguely remember from seeing it months ago on some YouTube video. So I don't think I'm going to go through this proof. But all you basically do is you just give these sides a number, then you give all these sides a letter, so you say this big side is B, this big side is A, and this side's C, this side's D, this side's E, and you just do a lot of trig with it to get this expression for sine 2 alpha, and then over here you can create an infinite series with the, which we haven't learned yet, but we will learn it eventually. You can create an infinite series with the side lengths, because you see the relationship between this is 2e squared c over d squared. This is 2e to the 4 c over d to the 4, and it just goes down, down. And because the triangle is going infinitely down, you can just model that as an infinite series, and then you just do a lot of algebra, and then eventually you get Pythagoras from it. All right, next question. This is the prime number one that you need to remember. You just let R be a set of primes, add 1 to it, and you just say that if you were to multiply all of them together plus 1, then it would divide, where therefore there wouldn't all of the other ones wouldn't be primes, which doesn't make any sense. Or not they wouldn't be primes, but if you add 1, it won't have a factor of any of them, therefore as being the last prime is wrong, because proving that any number calculator for that. Then you solve. I've rearranged here. You can see because the domain is x is greater than or equal to 0, it's only going to have one solution, which is when it's positive, which you can see from drawing the graph. Then next, state this thing here. I don't think I did this one right, actually. I think I just gave up on this one because I was taking too long. So, but what you should do is you should set it equal to k and then solve. Oh my god, wait, I'm an idiot. Wait, what? Oh, no, so you set this equal to k, and then you can just find where they intersect, which shouldn't be that difficult, actually. I don't know why I did that. But you can just see that you just find, all you have to do here is find when, you know that it's one of them is, the lowest part is when k equals 5, because that's when, and then I'm guessing you just do some sort of like discriminant stuff to find the other one, the other value of k, which you can see from the graph up here. Yeah, so, oh, what the hell have I done? Yeah, because it's going to be a graph like this, so you just find when, find at what points this happens, where this, where the line intersects twice. Alright, you can tell I'm getting a bit tired, but it's fine. Next question, we have the last question here, which is just some incline plane stuff. So we're going to say that we're going to resolve the thing, we're going to, I put mu_r question mark because half the time it's smooth, half the time it's rough. So for the smooth part, there's no mu_r, which means you can just resolve, and you can get this value here. You know that because the first sliding the first 0.7 meters is just we know that the acceleration is g sine 20, and therefore you can just use, oh my god, you can just use s equals ut plus half at squared to find t, and then explain when model A is underestimating the time taken. I just said there probably is friction. Then next, we know there's a different r now because we have friction. Therefore you just find r, and you find r, resolve, get a, and then get mu by resolving again. Right, long assignment today. Thanks for watching. I'll see you next week.